All right, let's start our lecture today. So this is EE 5907 or EE 5027. And as you know, the topic that we want to discuss in this module is pattern recognition. And specifically, we are talking about statistical pattern recognition. Right. So first of all, let's discuss the definition of pattern recognition. So when people ask you what you understand or what is the definition of pattern recognition, then what is your answer? Any ideas? Anyone wants to take this challenge to answer the definition of pattern recognition? Pattern recognition, the definition is exactly as its name. Means that we want to recognize patterns. Means regularities. This one means regularities. So we want to find regularities or patterns in the input data. This is something that we want to find the techniques. We want to find out the techniques to find regularities in the input data. And the detection or the recognition here have to be, of course, automated. Right? And another terms come up a lot in the discussion of pattern recognition is machine learning. So what is machine learning then, right? I'm not sure why the light suddenly off. So it's not good because you will sleep during the lectures. Is there someone in the box there or no? Okay, so yeah, good. No, it's okay. Right. So machine learning, right? So machine learning, the main part of machine learning is again to, as its name is to learn from data automatically. Learn from data. And when we say learn from data, it also means that we want to find patterns or regularities. So learning here it also implies patterns or regularities. So in other words, the definition of or the meaning of pattern recognition and machine learning are the same things. Machine learning implies pattern recognition implies machine learning. Because when we want to find patterns, we need to learn about the data. We need to find something in the regularities in the data. So when we talk about pattern recognition, it's here at least in this in the modules in this course we implies machine learning. Now, why machine learning algorithms is more powerful in many cases than traditional programming. So if you know about machine learning algorithms, machine learning is a part of algorithms actually. So this one is algorithm. And because this is part of the algorithm, then you have to compare this with traditional programming. Or traditional programming here, traditional programming or traditional algorithm. So what is the traditional programming? The traditional programming is that I'm not sure how many of you that from CS, from computer science. But in computer science, normally you will learn programming by knowing the step-by-step logic and then put the step-by-step logic into coding, into your code. In other words, traditional programming or algorithm is that human programmers has to know the answer first, has to know the algorithm first. So if you want to get from point A to point B, for example, there is a path here. So traditional programming means that you have to let the program, let the code know where to go. If you have some intersection there, for example, or some branches, then you have to tell the program that, look, if you want to go to B, then you have to turn the car. This kind of explicit instruction have to be there in the traditional programming. And that makes machine learning algorithm is different from traditional programming. Because in machine learning, you don't need to have this explicit instruction. Okay, so the difference is that in the traditional programming or algorithm, you have to have explicit instructions. All right. Any questions so far? Any comments? I'd like to have this module to be more interactive. So if you have comments or you have questions, please let me know. Okay, so that's the idea of traditional programming, that we need to have explicit instruction to be put into the code. Now, machine learning is different from this because we don't want to have this explicit instruction. This one says it doesn't need to have, no need to have explicit instruction. So what does it mean by non-explicit instruction? It means that you let a generic kind of programming, generic kind of algorithms that immediately learn from the data. Okay, so we want to get some pattern learning from the data. Now, why machine learning is more powerful than traditional programming? Anyone have any ideas? Why this machine learning algorithm is more powerful than traditional programming? Well, one of the direct answers for that is because explicit instruction means that we humans know the answer first. We know the answers, and then we tell the program, tell the computer to do something there. Means that we have to know the answer first. But in many cases in this world, even human doesn't know, even humans do not know the answers. Us do not know the answer, and we want to know the answer. And that's how machine learning is come. Because machine learning can go beyond our human knowledge. And that's the main thing about why machine learning is so powerful and why many people are afraid of it. Because it can go beyond humans' knowledge. And that's the goal of machine learning. It learns by itself beyond human instruction. Okay, so we will learn that concept later on in a mathematical way. But now let's keep that in mind intuitively. Okay, so that's the main thing that we want to learn here. Something that it can learn itself. Now, why humans do not know the answer? It seems to us that we know a lot of answers for many different problems, right? So now, why humans possibly not know the answer? What is the reason that humans do not know the answer? Anyone? Yes? Exactly. Because of the complexity of the data. What do they mean by the complexity of the data? Can you explain a bit more? Yeah, can you give an exact example? Right, yeah. Math can be complex. The simple thing is the Amazon database. You know, Amazon.com. People around the world worship in them. And who need data per day, per hour, per second? Million of data. And how humans can comprehend this data? It's beyond our range to comprehend this data. And that's why machine learning can help here, is important here. Because it can help us to understand complex, huge data. Not only in the numbers, but also in terms of the dimensionality of the data. We humans can imagine only three-dimensional world. But your data can go beyond the three-dimensional space. It can be 100 dimensions, it can be 1,000, 1 million dimensions. If it is 100 dimensions, or let alone 4 dimensions, 5 dimensions of data, human cannot imagine that anymore. So this is something beyond our knowledge. And machine learning with the help of mathematics doesn't really care about this dimensionality. So that's why machine learning is so powerful. It can go beyond our knowledge. And that's something that we want to learn in this course. That we want to learn the techniques that enable us to understand complex data by itself. All right, any questions so far? Okay, so if there's no questions, the typical task, so I write it here, typical task in machine learning or pattern recognition is first regression. We will learn about this regression a lot during this first part of this module. So regression means what? Regression means that if you have a data, so let's assume two-dimensional data, so for us to understand easily. So let's assume that we have a prices of house. So you have a house, you want to sell the house, and you want to see what will be the optimum price that you can sell the house. So throughout the here, so the x-axis is the here, and the y-axis is the price. And you look at your neighbor with somehow typically the same kind of house. You will see the pattern of the price plotted here. And the task of regression is to predict this pattern, to find this pattern here, maybe that kind of patterns. If you know these patterns throughout the year, then you know how to predict the next one. That's something that you want to predict. Oh, my price of the house could be in that point, roughly. So you will not offer sell it, or you don't want to put the expensive price because if it's too expensive, you will not buy. Or you don't want to put a much cheaper price because you will suffer. And this is, of course, beyond cost prices. It can be a stock market prediction, weather prediction, and a lot of other predictions. And this kind of prediction, predicting the price, predicting the value in the future or in the past, is called regression. Right. So aside from regression, what is the other typical part of machine learning or pattern recognition? I think many of you know about this already because many of you are PhD students or at least master students. The second part is classification. Classification is another typical task in machine learning that you have this two-dimensional space, for example. So this one is x1 and the other one is x2. X1 and x2 are the features or the coordinates of your data. We will learn later on about features. Right? But assume that you have two coordinates and this coordinate represents your data. And one of your data is a positive data, and the other data is negative data. And the task of classification is simply to divide these two different classes. And it means that you want to find a line, in this case it's linear classification, that divides positive from negative. So once you know this line that separates the positive and negative, in the testing stage or in the deployment stage, when you have a new data, for example, this is new data, it is not labeled, you do not know whether it is positive or negative. But after you see that data in this space, then you will be able to assess whether this is positive or this is negative. And in this case, obviously, that this one is positive data. It should be labeled as positive in the testing stage. Okay, so later on soon, we will learn about the stages in machine learning. In machine learning, we have at least two stages, training stage and testing stage or deployment stage, basically, okay, or generally. Anyway, so far, this is the two typical parts of machine learning. Any questions? Right, so if there's no questions, the third typical task is called, any idea? What will be the third typical task? Yeah, it's clustering. Right, so clustering is different from classification. The main difference between the two, although they are somehow similar to some extent, assume, well, you can have 2 dimensions or 3 dimensions, doesn't really matter. In this case, I just want to have 3-dimensional data. And your data is normally will not be labeled. There's no label on your data. In the classification, at least in the training stage, you will have positive and negative. But here in the clustering, normally you will not have the label. It means that you have data samples and another data sample here. The task of your algorithms, your clustering algorithm, is to cluster this data. It means that you cluster that into one type of class, you cluster this into another type of class, and cluster this into another type of cluster. So this is the main difference between clustering and classification. Classification, you have a labels, and then you try to find a line that divides the two separate classes. In clustering, you have a cluster of data, and then you want to cluster them so then they can be separated without any labels in the data. Any questions here? Right. So the next thing, oh, by the way, we will learn this in detail mathematically later on. Regression, classification, and clustering. Later on also, we will learn it, I think in one section in the second part of this course, you will learn about dimensionality reduction. Dimensionality reduction. So dimensionality reduction is another typical task in machine learning. The meaning of this is that assume you have a data that lives in a very high dimensionality. Okay, so because it is difficult to draw here more than 3 dimensions, so I just assume that my data in a high dimensionality here is in the 3-dimensional space. So let's assume that I have a data in 3-dimensional space. Right? So that kind of data. So I have a data here. Let's assume that I have a data here, sample of data. So like this. Right? Now, so you assume that this is a 3-dimensional space. So what does it mean by dimensionality reduction here? It means that your original dimensionality of the data, in this case, is 3D data. You have X, Y, and Z. But if you look carefully on that distribution of the data, what is the actual space of the data? What is the actual space of the data? It's only 2. Yeah, it's not 3, but actually 2. Means that actually you can unfold this. So you can unfold this. You can unfold this, unfold into something like this. Right? So this is called dimensionality reduction. The actual dimension of your data is actually much smaller than the dimensionality of your data itself. So the common idea is that, for example, if you have sample A, and sample B there, it seems in that 3-dimensional space, they are very close to each other. Compared to C, A look like very close to B. But actually, A and B is very far from each other. Because A is here, B is there, and C is here. Okay, so you have to be careful when you play with high-dimensional data. You have to be careful about this, because you need to learn the manifold of your data. If you don't know the manifold of the data, then you will assume that A and B are close to each other, but actually they are not. So that's why dimensionality reduction is very, very important. It is the underlying manifold of your data. Okay, so again, we will learn this regression classification will be the first part of the course. And then the second part of the course, you will learn about clustering and dimensionality reduction. Yes.
When you do dimensionality reduction, can you go more than one dimension while you're reducing, or you have to go step by step?
Yeah, good questions. Whether when we do the reduction here, whether we have to do it one by one, or we can just jump into the lowest dimensionality. The answer is the second. You can just jump from high dimension 100 dimensionality into 2-dimensionality. And that's the point. Because it is 100 dimensionality, it's highly difficult to imagine, to analyze the data. Then you have to convert this into much lower, in this case 2 or 3, that human can see and understand. Right? Yeah, good questions. Any other questions? Yes.
Dimensionality reduction will always put the optimal dimension, or you choose how many dimensions you want to do.
Yeah, that's another question. The answer for that, the question is that, whether we have to choose the dimensionality to know the manifold. This is an open problem, actually. We do not know. We do not know what is the dimension of the manifold. And that's the problem. Right? And that's the difficulty here. Many people spend their time on solving this problem. What will be the optimum dimensionality of the data? Right? Most cases, for human to be able to analyze, they just force the high dimensionality of data into 2 or 3. And this may not be correct because the manifold may be not in 2 and 3 dimensionality. Maybe they will be live in 5 dimensionality of data. Okay. So there is an underlying manifold, and there is there are 3 things here. One is the dimensionality of your raw data, the dimensionality of your correct manifold, and the space that you want to choose, which is 2 or 3. Okay, so the middle one, the manifold space, is the most difficult thing to find. Yeah, a good question. Any other questions? Yes. Oh, manifold is this one. This is called manifold. So you see that the data is actually in 3-dimensionality of space, x, y, z. But there is a manifold. There is a structure in the black ribbon there. Like the black ribbon is called manifold. We want to find that black ribbon. Another good question. So if you don't understand this part, so many terms here are technical terms, so maybe you are not familiar with the technical terms. So please ask if you don't understand. Okay, so if there are no questions, by the way, you will learn this in depth later on, just intuition. All right, so next is the common framework of machine learning. So this is the common framework. I say it's common. It's not really necessary, but it's a common one. The common framework of machine learning consists of training stage and testing stage. Okay. So for the training stage, we have input. To understand the framework, it's better to understand the input and the output, from the input and the output first. So for the training, assume that you use what is called supervised learning. So in supervised learning, you have training and testing. Actually, in the unsupervised, you also have training and testing in most cases. But let's assume we have supervised learning. What will be the input of your training stage in the supervised learning? Anyone? Data. Yes. The input is the training data and labels of the data. So in this case, the previous example that I gave to you, the positive and the negative are the labels. And what is the output? Predicted labels. No, that's wrong actually. This is where we are talking about training stage. What will be the output in the training stage? Exactly. The model parameters. So we will learn about this later on as well. What it means by model parameters. Okay. Right. So that's actually the input and output for the training stage. So for the testing, what will be the input? Yeah, that's data, exactly. Testing has the model parameter or? Exactly, that's something that I want to ask you actually. So this one should be also the input. Model parameters should be the other input. Because otherwise, how you can use the output of the training data, right? or the training stage. So the input is test data and model parameters. And what's the output then? Yes, this one is predicted label. Of the test data. Okay, so any questions here? So in other words, the goal of the training data, the goal here is to what? Yeah, to learn the model parameters. The goal of the training stage is to learn model parameters. And what is the goal here? It's obviously the goal here is to predict label. Predict the labels of the test data. All right. Any questions so far? I think we are discussing very basic things here. Yes. It is the parameters, the model itself. Yeah, the model. We will, don't worry, if you don't understand the question and the answer, don't worry about that. You will learn that mathematically soon. Okay, so you will see what it means by model parameters. Okay, any other questions? Right. If not, let's continue with the type of learning. I already mentioned that one of the type of learning, one is the supervised learning. Supervised means that this one, supervised means that you have the label there. That's the meaning of supervised learning. The label is something that can be considered as a form of supervision. Right. If you have supervised, of course, we also have non-supervised. And non-supervised is called unsupervised. What does it mean by unsupervised? It's basically you don't want to have the label there, right? Basically, there's no label in your training data. And if you don't have the label of training data, you can imagine something like this, something positive and negative, something like this one here. But now you don't have the positive and negative. Everything is just points here. Now it looks like become clustering. In this case, it looks like clustering now. So that's why clustering is mostly unsupervised. That's right. Okay. I'm not sure if we will learn about unsupervised learning. I don't think that we will have time to learn about unsupervised learning, unfortunately. But I can imagine if you take deep learning, there is a course called deep learning, you will somehow learn about unsupervised. Okay, you have supervised and you have unsupervised. The third type of learning is what? Someone say it's an enforcement learning, but that one is another one here. That's correct. Semi-supervised learning or semi-supervised learning. Semi-supervised learning means what? It means that at least some of the data will be labeled and the other data in the training stage. So we're always talking about training stage there. Some of the data will be labeled, some of the data will not be labeled. So that is called semi-supervised learning. All right. Any questions so far? Again, unfortunately, in this course, because this course is discussing about basic machine learning techniques, we will not go to semi-supervised learning. The only unsupervised learning topics that you will learn is PCA and LGA. But that one will be in the second part of the course. Right. So reinforcement learning is a bit different from the others, this supervised, unsupervised, and semi-supervised learning, because in reinforcement learning, you will take into account the feedback from the world. So it's not really a passive system. So what you learn here is a very passive system. Passive means that once you train, you deploy. It will never train again, you never listen and feedback. The system will never listen and feedback from the world. So that's why it's called passive system, passive learning system. But reinforcement learning is different because reinforcement learning is an active learning system. Means that it will learn the feedback from the environment and use the feedback to learn further. So reinforcement learning is a bit more complex. And again, it will not discuss in this course. In deep learning course, we will learn reinforcement learning. Yes, the example of reinforcement learning is the driving car. In driving self-driving cars, how you train the network, how you train the system, because the world is very dynamic, right? You cannot just train in one way of the road because there are many different ways of the road and many different environments. The pedestrian is different, the other car is also different. So how we can make the system learn? The system has to learn by itself through feedback. So for example, if there's a car on the right, and if the car moves to the right, it will bump each other, and that will give penalty. The feedback will be negative. But if it moves straight or moves the line, avoiding the collision, then it will get the positive reward. So this positive and negative reward will be used by the system to update the model parameters. So that's the idea, the concept of reinforcement learning. It's very, very different. Yes, very different. It's quite advanced. And again, if you're interested in that, you should take a deep learning course. I think it will be next semester. All right. Any other questions? Okay, so next, for the basic information, is the design cycle of supervised learning. But I will leave this later on. Design cycle of machine learning, I will discuss it later on through the slides. Let's discuss about classification example. So let's talk about a simple example. So in this example, let's try to learn how to recognize or to differentiate between apple and orange. So your task is to create a machine learning algorithm differentiating apples from orange and orange from apple. So your input is an image of apple and image of orange. So the steps here, the first step that you need to do first is what? If you have a receive images of apples and oranges. Yeah, extract the features, exactly. Processing the image so then you can have features. When we talk about features, what does it mean actually by features? Anyone has any ideas what do you mean by features? Yes. Yeah, in this case, for apple and orange, what will be the features? The color, exactly, color of the. Assume that apple is green and orange is orange, right? So you have color that differentiating the apple, the green apple from orange. So this is the color, this is RGB. It's a factor, RGB value. Aside from color, what else? The shape, right? So again, when we talk about features, it's not just human concept. It is a have to be mathematical concept. It means have to be numeric, has to be numbers. So here, when we talk about colors, we are talking about RGB, and RGB is actually value between 0 to 255. But when we talk about shape, here, how we can convert it into numbers? Yeah, we can get the center of the object and then find the area and whatever the place that we can define the shape. That's something that you need to do. It's not. That's why the picture here is not very easy sometimes because human have to define it. You have to define what is the meaning of shape. So most of the things, when we talk about feature extraction, it is handcrafted. Especially here for the shape. Handcrafted means that we humans have to define the features, the numbers. And we will learn later on that handcrafted feature is not true. Okay, so maybe some of you PhD students will learn about deep learning, know what the meaning of this, that deep learning doesn't like this handcrafted feature. That's why deep learning want to make it automatic. But most of the machine learning algorithms rely on these handcrafted features from humans in many techniques, including the techniques that we will learn in this course, especially the first part of the course. It will be handcrafted features. Any question on this for these handcrafted features? Okay, so the second step, well, it's not necessarily the second step, but intuitively you have to transform these features into the space, which is called feature space. You transform the feature into feature space. If you transform this feature into feature space, especially in RGB, if we focus on color, then we will have RGB space, RGB, from 0 here to 255, the maximum number of your pixel value on density. And then you plot this, the green apple and the orange, yes. So the oranges perhaps will be here. This is assume that you have oranges here. So let's put orange or red color. And then you have green apple. Okay, so this is the ideal case. Of course, in the reality will not be like this, but let's assume the green is green, the orange is already orange. So then you have this kind of feature space representing your data. And once you have this, the next step is what? The next step is the training process. You give this as input. You have sample data, this is training data, and you have the label, because now you have the green and the oranges, the positive and the negative. What you need to do is to create a model that separates these two. This is called a plane in this case, because you have three-dimensional space, not only just one line, but it becomes a plane. In the higher dimensionality, it's called hyperplane. We will learn that when you learn about SVM, spot-vector machine. Okay, so keep this in mind, that we have a plane separating the classics, the green and from the oranges. And this plane, that blue plane, has mathematical model, has a mathematical value. So for example, in this case, the simple mathematical model is AX plus BY plus CD equal to 0, or equal to D. Right? This is the mathematical representation of that plane. Now, when we talk about model parameters, when we say we want to estimate the model parameters, where are these? Where are these parameters in your equation? Exactly. A, B, C, D are the parameters. And that's parameter value that you have to obtain in order to separate between green and red. And that's what we call model parameters. So this one, A, B, C, D, are the values that we want to learn from your data. Any questions? Okay, so if there is no questions, basically that's the concept there. And of course, color is not everything here. Because, for example, now what happens if your apple is not green apple but red apple? And how you can differentiate between red apple and oranges? The color are very similar. And that's how you have to add more features. And in this case, we have the shape and maybe other things. So that's why features are very important. If you don't have a correct feature, whatever the techniques, machine learning techniques you use, you will fail. So features are the first most important things in the machine learning system. All right. But in this course, we don't learn about features because features is domain dependent. What does it mean by domain dependent? It means that if you want to apply machine learning to computer vision, your domain will be images. Your features will be taken from images. If your domain of application is speech, your domain will be signal, speech signal, and your feature based on this speech signal. If your domain application is a data mining, text, for example, then your feature based on the text. So features are domain specific. So that's why in this course, because this is about general machine learning, we will not discuss about feature extraction. If you want to learn about feature extraction for computer vision, you have to take visual computing. Another course in this semester. All right, any questions? Okay, so now the problem, as I mentioned again, if the feature is not distinguished now, then we have to add features. And adding features means what? You add more dimensionality. And if you add more features, it's more distinguished, but you have more dimensionality. And that will come into a problem. Well, it's a problem, I'm not sure, but it's a condition which is called curves of dimensionality. Why this is in the first place called curves of dimensionality? So this is called curves of dimensionality. Why is this called curves? Because for human, we cannot imagine anymore. We cannot see it. It is beyond 4 dimensions, or if it is 4 or beyond 4 dimensions, we cannot imagine. And it's much more complex. And that's why it's called curves of dimensionality. When the feature, although this will help you to improve the system, it also creates some problems. Yes.
Other problem that might cause is needing more data to train. When you add more dimension, you need more data relatively to train the same model.
Yes, that's true. We will learn that later on. When you have more data, more dimensionality, this is called model selection problem. We will learn that later on. We will see that. But it's not really general kind of assessment because in machine learning you have a few shot data, a few shot samples, and in that case it's not necessary that you have to be a problem. But anyway, so we will discuss hopefully your second lecture in the second part of the course. We'll discuss. Okay. Any other comment or questions? Right. So now we are talking about some positive things about machine learning, right? And we learned some basic concepts already. But machine learning suffers from problems as well. Problems in machine learning. I mean, problems here is something to do with the framework, something to do with the training and testing stage. Problem with the machine learning in that stage, one is called underfitting. is underfittings means underperform basically. And second, if it's there is underfitting, there is also overfitting. Yeah. So basically, underfitting, I can give you an example. Underfitting or underperforming that in the training, so we are talking about training stage here, right? So in the training, for example, you want, let's see, that you want to have regression of your fund. Your data look like this. The actual the actual model should perhaps do something like this. This is the actual perfect fitting. Assume that the perfect fitting will be the blue one. And the problem of underfitting is that your model is too simple. You learn too simple things. And if you learn too simple things, you might end up with something very simple like that. So the red line here is called underfitting. It's underperformed. And overfitting is another one, another the opposite way. Overfitting means that you fit very, very well. You fit this very, very well. Something like that. Now, which one is the best one from these three? The blue, the green, or the red? The blue. Why is that? Why not the green? Yeah, why not overfitting is not good? Exactly. So the idea of overfitting is that it's very good in the training, very, very perfect in the training, like the green one. But it performs badly in the testing stage. So that is the problem of the overfitting. So the problem of overfitting, underfitting, and perfect fitting is the same as what you experience perhaps in this course. Now you are in the stage of training. You are in the stage of training at this point of time. Later on, we will have exam, the final exam. The final exam is your first stage. Now, during this conversation, maybe during the small assignment or something, or when you learn yourself and you do the exercises, and if you cannot do the exercises in this stage, in this training stage, means what? Means you perform underperform. Your performance underperform. Because even in training stage, you cannot work on the exercise properly. If you cannot work on the exercises properly, you cannot hope that in the exam you will perform well. That's called underfitting. So what is overfitting? Overfitting is that during this stage, when you do the work on exercises, you done very, very well. But then when it's the final exam, your performance don't go. So why is that? What is the problem there? What is the problem with overfitting? Memorize it well. One of the problems of fitting is to memorize the fitting to complete the exercises, but then the person in the exam is slightly different from the exam. You memorize the fitting. So that's a two indication. You memorize, or the second problem is that there is a gap between the training data and the test data. If the test data and the training data have a lot of gap, and that's still for it is not generalizable to the test stage.
How do you differentiate between a self-fitting problem and a
Sorry?
how do you differentiate between a simple self-fitting problem and a regression problem. Like we have a polynomial, type of polynomial with that. And in parallel, we also do regression. So how do we differentiate? Both of them are same or
Yeah, so polynomial fitting and regressions are the same thing. We will discuss that soon, actually. So they are the same thing. So polynomial fitting and regression, and actually later on we will learn about Bayesian inference for regression. All of these are the same thing. Okay, so but you can just hold your question there. Once we arrive at that point, you maybe can ask again if it is later not that clear. Okay, any other questions? Yes. Yeah, later on we will discuss that. So I will discuss about the logistics of this course. Maybe after the break. All right. Any other questions? Okay, so if there's no question, I continue with this. So actually, you have to be careful with the training and the testing. First, aside from the training and testing, what else that you have training data, you have test data, what else that you need to have? Not really, I'm talking about the type of data that you need to use in your teaching process, training testing. It's called validation. It's called validation stage. So validation has something to do with overfitting. So overfitting, it means that you have a model. So this is your model. It is model complexity, right? So model complexity is like in your case, I'm not sure how many of you learn about deep learning. So model complexity is like epochs, for example. The iteration of the training. This is called model complexity. Or in some cases, in polynomial theory, that only we learn the number of the parameters. So the number of parameters, something to do with this example that I just gave to you. So this one. So this one, the model parameters have how many parameters? 4. But if I reduce it into 2 dimensions, how many parameters does I have? 3. So you see here, if I have higher dimensionality, then it will be 6, 7, 8, and so on and so forth. And that is called model complexity. Right? So the higher the dimensions that you have, the more complex the model that you will have. And that's something to do with this model complexity. Okay? So you will see that clearly in mathematical terms later on. If you don't understand that much, it's fine for now. So the other axis is error. Error with respect to your ground truth or label. So overfitting is happen when you have your curve to be like this. Maybe something more extreme like this. It means what? For example, in iteration 100 or in the model with the complexity of 100, means 100 dimensionality, the error is very low. Means that it works very well in the training stage. But in the validation process or in the validation data, the performance looks like this. It means what? It means when it is 100, the model complexity is 100, the error for the validation data is very high. This means overfitting. So if you choose your model as the output to be in this 100, for example, that's your model that you want to give us the output, then you will suffer from overfitting. So to avoid this overfitting problem, you use validation data. One of the ways, at least. Right? We will talk about this, how we deal with this problem later on mathematically as well. But for now, just imagine that if you want to solve this problem using validation data, then what you need is to find this perfect sweet spot there. This sweet spot means that the validation works in the best moment, at least for the validation data. And you assume that your validation data represents your past data, your deployment data. That's the basic function. If your validation is not the same as your past data or your deployment data, then, well, you're screwed. Right? You cannot do anything. All right. Any questions here? So that's the concept of validation data. So in the validation process, that is called k-fault validation. But I will not explain that today. Maybe later on you can learn about that. But that's the basic knowledge that you have to have. Okay, so I will skip some of the concepts, and because I assume that you know about that. If you don't, please ask questions. Yes.
Around 80-20%, or 80-20%.
Yeah.
So the validation will be 20%.
That's fine. So you cannot use the training data as your validation data. It has to be something different. The fact of the data has to be different. Now the problem is that what happens if you have limited data, right? Your data is only 100, and that's not enough to big. And then you have to use a fault validation. Means that you have to split in different ways. K times. Okay, any other questions? Again, this is just a review of the basic stuff here. Now, machine learning or pattern recognition, you have to keep this really in mind because it's really important. People always forget about this, even the experts. Machine learning follows some basic reasoning. Follows some very basic reasoning. When we talk about reasoning, at least we have two types of reasoning or logic. What are the two types of inference? When we do inference, there are two types of inferences, right? What are these two? One is called the deductive, and the other is called inductive. So, deductive, for example, all men, for example, are mortal. Socrates is a man. Hence, Socrates is mortal. Okay, so this is called deductive. This is a perfect inference. It's always correct. The fact that Socrates is mortal is correct, mathematically speaking. This is called deductive reasoning. So what is inductive? Anyone give a shot? What is inductive example of inductive learning? Well, I can give you an example here. All fonts are, well, to be specific, all font we have seen is white, or all are white. Then the inductive inference is what? All fonts are white. Okay, so this is called inductive, which is not always true. It is the knowledge is taken from subset to be generalized to more bigger set. That is called inductive. Now, human in daily life, when you make a decision, when you make an inference, it is deductive or inductive in most cases. How many of you say inductive? Can you raise your hand? How many of you say inductive? Inductive. Okay. So the correct one is inductive. The second one. Why we rely on the inductive, not deductive? Because to get into deductive, you will have to have a complete picture of the situation. You have to have complete information of all the things. For example, if you are a boy, a girl, comes to the door. And then what is the decision? Say yes or say no. While perhaps you have something that falls out of the room. So there are many information whether you have chance to get the girl that you want or you want to say yes to this girl that comes out. It's a very marvelous. Because the chance of you to have a possibility, for example, to rely on this decision. And you know, to gather all the information that you can get someone to be worldwide is a complex problem. And you have to make decisions because otherwise you are too old to get married. So in this situation, when you have to make decisions, without enough information and time, which is one of the cases that we face in life, you rely on inductive reasoning. Because otherwise, if you just look and look and look and look until you certain, you will never make a decision. So that's the basic idea of machine learning. Machine learning is like human, it relies on inductive reasoning. It's not always correct. So keep in mind that machine learning output is not always correct. It can be wrong. Okay? Because it's relying on inductive reasoning. Right. Any question here? Okay, so if there is no question, I just want to ask a question. So it seems now that machine learning is powerful, but there is a problem here with the inference, with the reasoning. Also, there's some basic problem of machine learning. Can you mention at least one basic machine learning problem? When you are a programmer, someone asks you, what is your boss asks you, what is the most basic problem of machine learning algorithm? You know, computational power is fine. You know, you can always find a machine that is better than your boss has money to buy you bigger CPU or more. Exactly. The problem with machine learning is that it relies on data. If you don't have data, then you cannot do anything with machine learning. You cannot bring a model. And more problematic than that is that your data can be biased. And this is a real problem in the world. Facebook has this problem. Google has this problem. Amazon has this problem. That your data is biased. And if your data is biased, your model will be biased. Your decision will be biased. So that's why you have to machine learning. It can be rely too much on your data. And the problem is that the data is created by humans most of the time. And humans can be very, very biased. So that's a main drawback of this machine learning. It's very powerful, but it's a fundamental problem. All right, any questions? Yes.
So we can have this the reasoning to get to the result. Usually we have the input data like observed data or like experimental data. The black box is now for
So you say that humans deductive instead of your body. So machine learning, for example, if you have a black box, you have a data, then you have some model. Right? And this mapping from data to model is deductive. I agree with you on that. That this process, mapping is deductive. It's mathematical mapping function. I'm not talking about that. I'm talking about generalization of this model. So once you train this model from your data, the data is a subset of the world, right? And then you apply this in the deployment to the world data. So from the small data that you learn to the bigger data in the testing, there's a problem there, right? Because your training data is a small part, but your real problem deployment is large complex data. And that is a problem there, because it's small to large. It is enough to nature. Okay. Any other questions? Yeah, I think that's a good question. The mapping, the learning function is actually deductive, but I'm not talking about that. I'm talking about the generalization of the model. Okay, any questions? Any other questions? Anyone? Okay, so if not, let's now get something real, get something more mathematics. So the next one, we learn about these squares. This square regression. So first we discuss about this square regressions. Okay, so this square regression, as I mentioned again, the basic idea is that you want to do the fitting on this type of data. Assume that you have a here, here, and price, part of your car. All right. So now, again, the idea of regression is to try to fit a line on this data. The line can be curved. It's not linear. Okay. Now, the solution for this, assume, to make it simple, the price of y exists here. So first in the step, you need to have called data modeling. In the data modeling here, let's take something simple, very, very simple for our early discussion here, which y x w0. Don't worry about w0 and x. X is actually here, x. So you have many, many x, right? X's. And I put x bar as our factors. So means x bar here means that you have x1, x2 until xn, and here is the number of your data. It means that this one is x1, this one x2, and so on until you have this xn. Okay, so that is your data. And y is the model, your model, data model. And your data model, let's make it very simple. Let's put just one constant value w0. If I put very simple a scalar value w0, how can I draw the line? It's a straight bar, it's horizontal, right? If I try to draw a horizontal line on the graph, where it will be? Where will be the horizontal line likely to be? Anyone? Exactly, the average, right? The line here will be the average. How can you know that it's average? How do you know that it will be average? Average from all these points, right? Basically. That's something that I want to prove here. It will be average. How can we know? So first of all, you have a data modeling, and that's the modeling, the very simple modeling that you can do. And second is you have to define your error function. So error function here, throughout this discussion, it will be multiple times until the end of the first part of the course. I will use E. E is an error function. Error function with respect to the parameters that you want to estimate. So W here, W0 here. So the W0 here is actually that one, that red line. And we want to know what is the value of this W0. And someone here, your classmate here mentioned about this has to be average. Okay. So how we can define the error function? What is the one of the most popular error function? Anyone? Sorry? Exactly, L2 or quadratic function. So L2 alpha is the function. We put 1 over 2, the sum over all the data from n equal to 1 until n, until the number of your data. Of what? The difference between. Exactly. So the y here is your prediction, and your actual value is your ground truth, which I put as Tn. So we have yn, we have Tn squared. This is square root. Square means it is at the norm. Now the question is that why do I need to have half that? Why do I need to have 1 over 2? Exactly. Later on in the optimization, it will be cancelled out. It doesn't really matter whether you have 1 over 2 or not. It's just for convenience. I will show you this. Right. So and yn is defined as this one. That's how you define yn, right? This one is yn. Regardless the n, regardless the index of n is always w0 in this case. So I can change this into w0. So that's the error function that you have, w0 minus 2n squared. Any questions here? This is very bad. You have to understand. Otherwise, you will get lost all along the way until the end. If you don't understand, it's hard. The discussion that we will have will all mathematics like this. So the first thing that I just discussed with you with intuition and so on is only that one. The rest will be all mathematics. So if you don't understand, please ask. Okay, so once you have these error functions, then the third step is to do optimization. In this case, the optimization will be minimization. Sometimes people use maximization as well. I will explain later on when we talk about MLE and MLP, MLE and MLP about maximization. But in this class, I will use minimization. There's no difference in the two, but it's more convenient to have minimization because the minimum will be 0. And if it's maximization, you cannot know the bound. It can be infinite. Anyway, so in minimization, the language that we use mathematically is that we want to know what is the output of this exercise. What will be the output of this? To know what? Yes, the minimum. What is the variable that we want to know? Mathematical variable. What is the mathematical variable that we want to know? Anyone? In this mathematical equation here, where is the variable that we want to have in the end? W0, right? Because W0 represents the line, the red line. So we want to get W0 here. So we want to get W0, the optimum one. Means that we want to have the optimum one with the star. Star means the optimum value of W0. And this one, because we do the minimization, what is the expression that I have to use? Argument mean with respect to what? With respect to W0, of course, right? And this one is EW0. That's the idea of minimization. What does it mean by this? It means that if I have all possible value of W0, so the x-axis will be W0, all the candidates from 0 to 1 to 2 to 3 and so on. Right? This is the possible values of W0, basically, the x-axis. And the y-axis is what? What will be the y-axis? Yes, the EW0, right? And it's likely that the graph here will be what? How the graph look like? It's likely to be quadratic, because our error function is quadratic. Quadratic means that it's like this, right? And we want to do what? Minimization. Minimization means what? So find the minimum. Where is the minimum here? Means that we want to find that point there, right? And where is W0 start? Where is it here? This one is there. That is what it means by argument mean. Okay, so this is very basic. If you don't understand this, you will get lost all along the way until the end of the first part. Please try to understand this. If I don't use argument main, but I just use mean, for example, what happens then? It means what? If I just use mean, it will be pointing to this part here. So this is B. B is the mean of E. So this one is mean of E. But if I use R, here, then it is the x-axis. If I just use mean, then it's y-axis. Okay. So because we want to have W0, then it will be the x-axis. That's why we use R mean. And this one, the parenthesis here, the parenthesis there, W0, and the parenthesis is candidates. All these, all that is in candidates. 0, 1, or 1.5, 1.2, 1.3, until so on and so forth. That is called candidates. So this one is called candidates. With respect to all these candidates, we want to find the minimum one, the one that makes the function minimum. Right? So this is the mathematical language that we really have to understand. So now let's get back into this. So we want to have argument means EW0. It means that we have argument means W0, then we just have a 1 over 2 sum over n W0 minus dn squared. Now the question is, how can we do the optimization? How can we solve this? If you want to solve it, how we can solve this? Yes, because it's quadratic. Quadratic means what? Quadratic is something like this one, right? This one. If you take the gradients means what? The gradient means the change of the slope here. That's called gradient. The slope here is called gradient. And the slope, when you want to find that point, the slope equals to 0 because there is no slope. Basically, the slope will be constant like that. So the slope will be 0. If the slope will be 0, means that if I have E as a function of this one, of E equal to 1 over 2 sum of n W0 minus Tn is E, then the derivative of E, because this one is E, right? So this curve here is E basically. And if you want to know the gradient of E, what we define as the gradient of E is dE dW0. This is the meaning of gradient. And it has to be equal to 0 because we want to find that point. So what is the derivative of dE W0 here? Anyone? So this one equals to sum over n. Sum over n, when you do the derivative, is still sum, right? And W0 minus Tn. Okay. So now, again, in the end, what you want to find here? Which variables that you want to find? W0 is something that you want to find. So if you want to find W0, then this one is equally sum over n of W0 plus sum over n Tn, correct? And it's equal to 0. So this one equal to 0. It means that, oh, sorry, it's not plus, it's minus. It means that W0 sum over n, sum over n1 equals to sum over n Tn. what is the sum of 1 over n? It's n. So W0 equals to 1 over n, sum over n, Tn. So this one is your value. Right? And what is that? It's average of your Tn. So what is your Tn? Tn is this value here. So this one is T1, T2, T3, T4, is whatever until the end. So the average of your Tn is the answer of what it is. And it's proven here now. So this is basically regression. And where the machine learning here? Well, the machine learning is very simple. Try to get the W0. Of course, it's not yet machine learning, it's just mathematical exercise. Because the number of parameters is only one. Any questions? So as you can see here, in this course, especially the first part, you need to know about at least calculus. If the calculus is not that much, or you forget some of them, for example, you need to brush up your calculus. Okay, so the derivative and integral will be part of the discussion. And later on, we will see that you need also to have some basic knowledge and probability and statistics. Anyway, so that's the idea. Any questions here? Now, this one, as you can see here, the model that we use is not that complex. And it's too simple, right? The data, the model of the straight line is too simple. So this one is not really realistic. So we have to remove this. And further on, we have to change the model, the fitting model. And the more complex fitting model, in this case, for example, you can imagine a straight line in that direction. Okay? So in this case, the first thing that we need to do, again, is data modeling. Data modeling is very important. So keep this in mind. Then y x bar w bar equals to what then? If I have a straight line like that, equals to, well, this one is xn, right? If I have, let's assume that I just want to have modeling of one data xn. So this is xn w1 plus w0. This is the same like ax plus b, right? Equals to y. It's a straight line equation. I just changed a and b into w and w1. So then when I say w bar, when I say w bar, it's actually w0 and w1. Okay, so this is a bit more complex because we have two variables to learn. But the fact is the same, that you have error function. And in this error function, you have EW bar now, which is W1 and W2. And this one is exactly the same, sum over n, y xn minus the n squared. Any questions so far? And the third fact is the same again, it's optimization. In this optimization, we want to have a W bar star that minimize EW bar. And again, the problem here that you need to solve is that the optimization here implies, because it's quadratic, it implies that you want to find the derivative equal to 0, the flat point of the curve. So But of course, this one is not two-dimensional space. Actually, you have to imagine now W1 and W2 in three-dimensional space. And your curve is actually three-dimensional curve, something like that. This curve, three-dimensional curve, is EW0, W1. Okay? But the same again, mathematics doesn't care about dimensionality. If it is derivative, it's derivative, right? But intuitively, that's something that you want to find. This is a point then. Right? Okay, so I just want to complete here that it's E. So TE, in this case, because we have two variables, you have TW0 equal to 0, and the other one is TE, TW1 equal to 0. So you have two variables that you have to optimize. The basic thing is the same. So if you do the derivative with respect to W0, for example, then it's the sum over n, W0 plus xn multiplied by W1 minus Tn, that's it, equals to 0. So in the end, you will have W0 equals to 1 over n, sum over Tn minus sum over n, xn W1. Right? So which one that you have? So this part here is something that you have, which is known. This is your data, right? The data in the price of the houses over the year. That's your TN. So you have that, it's known. XN is the year of the data. Of each of the TN, you have the year. So this is also known. The only unknown here that you have to find is W1. W1 is unknown. Okay? So W1 here is unknown. Now, this is one equation with two unknowns, W0 and W1. You cannot solve this, right? So in order to be able to solve, then you have to work out on the second equation. Okay, so the second equation, if you do the derivative again, it's the same thing, the same process. W0 plus xn W1 minus Tn multiplied by anyone? Multiplied by xn equal to 0. Right? It's the derivative of with respect to W1. And in this case, W1 equals to sum over n, Tn xn minus W0 xn divided by sum of n xn squared. Now again, everything here is known except this one. That one is still unknown. Right? Now the question is that, can we solve this equation? Can we get W1 and W0? The answer is yes. Why is that? Exactly. Two equations are unknown, so it can be solved in a closed form manner. Okay, so in the end, you get W0 and W1. And if you get W0 and W1, you will get the correct value of the parameters of the line. Okay? Any questions? Any question, anyone? I assume that you understand so far the mathematical process here. But again, people will argue that this might not be correct. This line might be not correct. Right? If it is not correct, then what is the possibility? Maybe the data should be quadratic, or maybe that has to be cubic, or maybe this has to be quark or whatever. The power is to 4, for example. If the power to 4, it will be like that. if the power into 5, it will be more complex than complex, right? So how to represent this curve? With many number of powers. It's called exactly polynomial function. So we want to model not just a straight horizontal line of the straight line, but we want to have a model that complex enough to deal with our complex data. Okay, so in that case, we use what is called polynomial function to model our data. Polynomial functions. So the first step is to data modeling. So in the data modeling, because we want to capture any possible function, any possible shape of your data, then we want to describe it as y, xn, w bar. So I just go, okay, so let's do it later, bit by bit, so it's not too fast. Okay, so I just want to have a pause here. Any questions? I want to you further. So as you can see here, it can be more and more complex. So we go into the more complex system. Any questions? Okay, so if there is no questions, let's have a break. 15 minutes. So 15 minutes. 7:50. We resume the discussion. Okay, let's have a break, everyone. No. Your name is. Yeah. Think there is a linear regression, linear model regression, linear model of classification. I think it will be up to that point in the model of classification. But if you have time, we will go up to the kernel. Yeah, the first part. Yeah. So linear model for classification is a model for the regression, and if we have time, we will discuss about kernel. It's a factor. So one, two, not two is a of course important is a constant distribution. 1, 2, 3, 4, 6. 1, 2. Correct info this one. We are just because we have two processes here. E5 9025. Oh, it's fine. You don't need to have oh, I will put the information from the after the thing. And I will put that in the no, the other one. The other one, no, so this one. Okay, so 507, you don't need to have and then so but if 507, then you need to have oh, okay, so you have to all the information everything. So if you don't get the information that you want, yeah, 1/2 is not really meaningful. Well, if you do the derivative, you have to put this 2 in front of the function, and the 2 is meaningless.
Only one is to minimize it.
Yeah. So that So one of the two is just to cancel when you do the derivative.
Yeah, yeah. When we do the latest stuff,
Yeah.
we use D DE on the W to
Yeah, that will take it cancel
so that's why we define the
in that way. Yeah. It's easy for kind of paper I think. So we don't really bother what two anymore. Although even if there is two, it doesn't really matter. It's the same thing. You know, I read a lot of emails. The problem is that we don't have the capacity anymore.
So if you want to,
If you, yeah, you can come here, or you can, if you want to be the guest.
I like to.
Oh, okay. So if you want to be the guest, you can also email me, you know, you mentioned that you want to be the guest. If you want to be the guest, then you will go to the system. So if there's an announcement, you will receive the announcement.
So we can join the.
Yeah, you can audit the class. Audit the class means that you will be part of the system, but you will not have the credit.
Yeah.
You don't need to. You cannot take it. You cannot take it. Yes. That's one important thing. Yeah. So this two problems are very popular in the problem with the manpower. At the moment, because we cannot use because again,
Our screen.
oh, really? Yeah. So you have to complain with the department. Yeah. So the office is speaking, you have to say that. Unfortunately, but I cannot hear the legislation. As a instructor, I cannot do anything.
The problem is the development of the problem is not allowed to
The
lecture.
The fact that two lecturers is for the training which is sometimes, but when it's problem of manpower, what is the problem of the manpower here is that, you know, it's just question, for example, I have to have a GA to help me to answer all the questions.
Yeah.
If you have a project with your assignment, for example, I have a GA to help you. I cannot do it by myself.
Yeah.
So this manpower of GA is not enough. So that's why the limitation. Unfortunately, I cannot help because the cost is already through. Again, if your situation is really, you have to take it unless you have to graduate, for example, then you have to help with the department. Because this is a bit beyond my capacity. Yeah. So if you audit the cost, because we still have seen it. The main problem why we limit the cost is because we don't have enough GA to help me to manage the cost. You can email me and I will put the system. Yeah. So you will receive the announcement if there's an announcement. Yes, I can hear you. So just mention that you want to audit. Yeah. Be careful with that. It's one very popular. So you have to be quick. Yeah, I will do that. Half of the cost. I just want to half. I will let you know later on. You can No, we don't have. It's all individual. Yeah. Yeah, that's how it's kind of have to go to because the demand is very high. I receive a lot of emails from students, but I cannot do anything because of the lack of manpower. So you have to complain to the department. But then that's where the problem is. So I'm going to I can't do anything for myself. What I can do is to talk to the things that I'm making yeah, I think we already I cannot form because the I try my best to keep yeah, that one would be used. The one actually the exercise is the second one from no, in some point, I would like to know the question is between the main textbook, particularly about the
So all definitely most of the
no, it's less complex.
so we're looking right.
I don't think so because it's too many, so we cannot do the marketing. All right, let's start the second section. Right, everyone, we start the second section here. So I just want to remind you that if you are a student of EE5027, EE5027, you have to fill in your attendance list here. Okay, so if you that student, you have to write down because it's mandatory. Okay, so I assume that you all from 507 have signed that form. Okay, so let's continue our discussion. I will discuss a bit on the logistics. So the topics that we cover in this module, there are two parts. One is by me, and the other is by Dr. By Stone. So it's not by Stone, but it's by Stone. Right. So the first part is typically the same as EE5027. So EE5027 will not have the second part, but it will be replaced by EE5026. So in the first part, we will discuss more into the fundamental concept of machine learning, and we will discuss mainly on Bayesian inference and linear model for regression classification. So this is the topic that we will cover in the first part mostly, and if we have time, we will discuss conversion processes. But I'm not really sure if we can get into that point though. But in the second part, there will be more topics on LDA, and PPA, clustering, and so on, and introduction to deep learning. Now we'll see, now we get it. Yeah.
EE5026 offers the
EE5026. I'm not sure. I think so. But it's only half. Any other questions? Okay. For the GA, right? So people who help you for the assignment or any problems that you have for your learning, these people are basically the people who help you. So there are three GAs. One is Fang, Heng Yuan, and Shaka. Okay. So if you have any problem with your assignment or any question regarding your practicality, practical problems, please contact them. Yes, any questions, Daniel? This slide will be uploaded here. Yes, we provided to you, including the lecture notes. So the lecture notes, I will please handwritten lecture notes. It's not supposed to be your material, but for your learning process, I will release this as well. Because the one I just wrote mathematically all the things, it is really like no diagonal. But again, diagonal is not the source of the information. It is actually for me when I am doing the teaching. Okay, so please don't complain why the writing in the taking note is not good. Right? So it's really because it's not supposed to be used for you. Yeah. The recording will be there, will be shared with you. So I'm actually recording this. Hopefully it works properly, right? So every lecture that we have will be recorded. And I will be available on the minute. Any other questions? Yes.
I just want to make sure I understand. There's a hundred four, 105.27. But there's no hundred four, 9 or. So I just want to why would you
No. Or if you are student of 5.907, you don't need to have it. All right. Okay. So the main references. So this is the textbook, the reference. So mostly the handwriting that our thing to you is taken from this property short group. So the book that I use for explaining the mathematical things, including the polynomial function today, is taken from this book. Okay, so that will be, it's not just the main, perhaps it's the main, but I also use other textbooks. Okay, so because it's a graduate course, it's not just focused on one textbook, it will be a few textbooks like this. But I will share this information in the website. So which things that you have to read will be provided on the website. The good thing is that these main textbooks, at least 2 of them, are free. Okay, the PDF is available online. Any questions so far? Okay, so the prerequisites. The prerequisite for this module will be probability, statistics, linear algebra, and actually calculus. Right? And for the assignment, you need to know about programming in Python, and especially the use of Jupyter Notebook. So your submission has to be in the Jupyter Notebook format. Okay, so please keep in mind this one. We will not accept any other format aside from this Jupyter Notebook. Any questions? Any question, anyone? All right, so you will find this class very difficult if you don't have the prerequisite, especially the mathematics, because our language in this course will be all mathematics, linear algebra, probability, statistics, and calculus. And also, so obviously it's a graduate course. So it will be more difficult than your undergraduate courses. Any questions for this prerequisite and the program requirements? Okay, good. The next thing is the state of the art. So again, this one, this course do not cover the state of the art techniques or algorithms. And this only teach you the basic concept to understand the state of the art. For more state of the art techniques, you have to look at this conference table. And we will not cover that much on deep learning. Later on, the second part, the deep learning will be also in the introductory level. Okay, so just keep in mind, because we just want to have the basic concept in this form. Right, so this one is maybe more important. The information is on Luminous, especially the website. Right? For this website, you can visit that link. I cannot click. So the easiest way to access my website is to type my name. So if you type my name, then you will have, oh, by the way, my name is Profitan. So you can just click that one, and then you have teaching there, and then you have the pattern recognition, and that's it. That's the corporate site. Right? In this corporate site, you will have the reading material, and later on also the lecture notes and the slide. It is only cover the first part. I'm not sure of the second part. The second part will be announced by the instructor, Dr. Bai Song. Any questions here? And the assignments have to be submitted via the minutes. And the deadline are strict. And there will be two GAs, one for the first part and one for the second part. Again, for the two GAs, the deadline are strict. Late submission will be deducted automatically if it is beyond the deadline. 2 points in the first or in the every 24 hours. Any questions on this? Yes.
How many assignments do you have? And
The assignment will be two. One is the first part and one is the second part. Roughly the first week. Because I think now we will have the knowledge to work on it. Yes.
that's very interesting.
Everything will be individual. Yes. Any other questions? Yes. First, yes. Sorry again. So weightage. I will give you the information at the top. Yeah. Any other questions here in there? Oh, okay. Yeah. So I will give you the information. Any questions about this assignment? Okay, so this is the weightage of assessment. So the CA, each of them is 20%, 2 CA is 40%, and the final exam will be 60%. Right? So for EE 5027, you will only have one CA, but the weightage will be the same. Any other questions here? No? So yeah, copying is not really not permitted. Okay. And the academic and the weightage have to be checked. You have to obey the academic policy there. It is not only for CA, but also for exam. So it's likely because the number of students here, the format of the exam will be multiple responses. It's not multiple choices, but it's multiple responses. So in multiple responses, there will be can be more than one correct answer. Because it's all multiple responses. And because it's multiple responses, the possibility of cheating will be there. Okay. Last year, we had a big problem. About 10 students cheated. And some of them are expelled from the unit. So please don't do that. The risk is so high. Some of them, even though the students, we will not research, but very good, students. First, they have to leave the university, some that expelled because of the cheating in this course. So please don't do that. All right. So that is the academic integrity has to be maintained. We will have a strict yes.
The format of the exam is online or
It's not online. Everything here will be face to face. Yeah. Any other questions? Oh, by the way, that's the kind of thing. I mean, if the situation gets worse, for example, then we have to follow the documents. Yes. Sorry again. The format is not responsive. Yes, so it's not multiple choices, it's not multiple response. Means that there will be possibly correct answer more than one. Our discussion is mathematics. So there will be not unavoidable to have a mathematical questions before the exam. Any other questions? Yes. Programming in the final exam, that's good questions. It's multiple responses, but the number of responses, it can be avoided. What will be the type of this it might not be quite controlled, but it still be algorithmic. I can speak on my behalf, on the behalf of the first part. So the second part, we have to make sure that the same question that we need to ask to the okay, any other questions? Okay, good. Okay, so that's all for the logistics. If you have any other questions beyond this, you can ask now for the logistics. Anything that we need to ask? Okay, good. If there is no other questions, let's look at the overall reflect there again about what we discussed so far. So in on the slide, we're talking here about AI. So AI is intelligent, obviously, displayed by machines, and this is the unsolved problem. Obviously, we're still doing this, and since 1950s, people tried, actually beyond this 1950s, even before 1950s, actually people dream about this artificial intelligence. And this recent research in RNR is made possible by machine learning in the first place and deep learning in the second place, right? So this is two powerful tools in the machine learning and deep learning. Right. So and pattern recognition, as we discussed in the beginning, is exactly the same thing like machine learning. Pattern recognition is automatically detect patterns from data, and machine learning is learn from data without being explicitly programmed. So we learned about this in the beginning of this lecture. Any questions here? Right. Then again, machine learning and pattern recognition are used interchangeably, and there are many applications of this machine learning and pattern recognition. There will be email spam detection, speech recognition, handwritten digit recognition, Google search, regular car, banking protection, and so on and so forth. Even in many almost all different fields, nowadays they use deep learning, machine learning. Okay, so machine learning is everywhere. And because it's everywhere, the demand for people that possess this, that have this knowledge is very high. Okay, so this is a Google Assistant concept. You know this already because you can speak to Siri, and maybe you can also speak to the Google Assistant, Alexa, and so on. And you also know about this Amazon Go. You can go to the store without queuing when you have to leave to pay the bar. And all is possible because of AI, because of machine learning, deep learning. Okay, so we also discussed about type of machine learning. We talk about supervised learning. Again, in the definition here, supervised learning, given the input and the output pairs, right? So in this case, the xi and yi. Xi is the data, and yi is the label. So this is supervised. Then you want to learn about the model, right? So, and just keep all this. So basically, Why is the target variables that you want to learn in the testing, you want to predict in the testing. And the basic idea is again that you have the label. The label here is the Y, and X is the data. Okay, so we learned about this usually in the first part of the lecture today, and this is unsupervised learning. In this unsupervised learning, as you can see there, the difference is that in this part you have YI, but in this part here and for unsupervised, you don't have Y, you don't have the label. Okay? And this is the basic idea that you basically do the clustering. You just cluster the image based on the appearance, based on the features. Right. So this is the basic concept that we learned about supervised and unsupervised. I think we already covered this. And right. So this is the basic idea of things that is not covered with the semi-supervised learning and the reinforcement learning. And again, the reinforcement learning is looking at the environment to learn further. And this is something that we will not learn in the future. So again, any questions from the quick review on what we learned in the first part? Right, some background here. So I just want to, this is something that I didn't bring before. There is a design cycle in machine learning, especially in supervised learning. First of all, you need to collect data. So here you need to collect data as the first step. And then the second step, you have to choose the feature. We talk about the feature for the case of oranges and apple in terms of the color, in terms of the shape, right? So it's called feature. You have to choose the feature. It means that it's handcrafted feature. You have to decide the feature. And then after you choose the feature, you choose the model. The model is the one that I mentioned to you, whether it's horizontal line or whether it's a straight line or whether it's a polynomial function. All of these are the models. You have to choose the model. Or in this case, you choose the polynomial function, the more general model, right? For the case of regression. It's not that you have to be regression, it's not going to be polynomial. Later on, you will learn basis function. That's another model that you can use. And the basis function is much more powerful than polynomial function. But again, this kind of function is something that you have to choose at the moment. You cannot do it automatically, unfortunately. But that one is very high level of models that you need to choose. Then after we know the model, whether it's polynomial, whether it's basis function, then you train the classifier. You train the model to get what? To get the parameters of the model. And once you have the parameters of the model, then you will you can train the system already, the training system. So in this case, in this example, you can have pre-processing to get the features, and then you can have a feature extraction. Pre-processing here is like noise or English enhancement or low light coefficient pre-processing. Then you can extract features based on this pre-processed image, and then you can have classification. And in this classification, you can have a Salmon or T-bar in this particular example. So that's all design cycle. So basically, this is explaining what I just mentioned. The pre-processing here can image enhancement, removing the background, removing the noise, enhancing the degradation, if there's any degradation in your data. Right, so basically that's the idea of the design cycle. Any questions here? Okay, so if there is no question, I just want to quickly review whatever the things here, right? So feature engineering is very important. Again, the features here is the color, the shape of the things that you want to use as a feature. So in this case, the simple case here, for example, the length of the piece. So the length of the piece can indicate whether this is Salmon or T-bars. But of course, there is a huge overlap. So the red one is T-bars, the black one is Salmon. If you look at the length, most of the T-bars is longer than Salmon, but not all of them. But again, you then need to choose the error. If you have to use the length, for example, then there is no way to perfectly separate them. You will end up with some sacrifice there. So this one is something that you have to sacrifice here, right? The red in the left and the black on the right. That's something that you have to sacrifice. Means that if you do the optimization, reducing the error, and choosing one single separation in this case, then it will not be that accurate. Okay, so in many cases, there is something that you will have in your real application. That the separation between the features will not be 100%. Of course, we want to have features that separate as much as possible. Anyway, so yeah, so this is again the length here. Although this one is, if you do the mathematical optimization, you will get that line to separate the symbols and the sound. That's from the mathematical point of view when you have to minimizing the errors of the one group. For example, this one using part of the function. But whether this is the best separation for us is a question mark. For mathematical point of view, yes, this is the best. But from human perspective, it might not be the case. Because if you separate in this case, for example, there are many salmon considered to be sea bar, or the other way around, sea bar here considered to be salmon. So, for example, if sea bar is cheaper than salmon, people do not like it. They might want to have more strict to the salmon as the error function. Why? Because salmon is more expensive, for example, than sea bar. People will more upset when they want to pay salmon but receive sea bar than the other way around. Okay, so for that reason, you want to reduce the disappointment of the customer. If you want to reduce the disappointment of the customer, then you have to adjust this separation line. Because people will not upset when they buy sea bar but receive salmon. Okay, so that's the underlying idea how to make this decision theory. There are some theory about the decision that you have to consider. It's not always a mathematical decision that is there. So you have to be careful with that. Okay, so anyway, so in this course, though, we will stick with the mathematical solution. So we will not take into account the human valuation. We will take into account only from the error function, whatever the error function that you define there. Okay, so anyway, so as I mentioned again, not all errors are equal. Some error is more profitable than the other errors from human perspective. Okay, so I think that's all. I think I don't want to talk about higher concepts because we already covered this in the first part. But I will share this with you. You know, you will learn about terms of dimensionality. You will learn about we have to learn about model complexity as well, and so on and so forth. Okay, so for this quick review, any questions? Any question for the quick review? If not, then we continue with our mathematical discussion. Okay, so we mentioned that in the beginning, the main problem is that for this price from the regression, we do not know what is the underlying curve of this distribution. Maybe the underlying curve of this distribution is a line. Maybe not. Maybe this one is much more complex, right? So whether this is a simple line, whether this is a very complex curve, we do not know because we can see the data. In most cases, we can see the data. Why? Because the data occupies very high dimensionality of space. We cannot see it.
if you don't see how can you define it, it's a straight line or a curve. So there is a problem there. How can we define the curve? How can we know the curve? So because we do not know the curve, we make the expression of the curve more general. So what does it mean by generalization of the model? So in the data modeling, so in the data modeling, again, if it is horizontal line, so if we have horizontal line, then it's very simple that y equals to W0, right? If it is linear slope, then y equals to W0 plus W1 xn for yn. This is yn here. Okay. So I hope you understand what is yn, right? Yn is the prediction of that sample n, the price for that sample n. So that's why it's yn. And it has to be close up to Tn. Tn is the price that's given to you. Okay, so Tn is the price is given to you, and yn is the prediction of that Tn. Okay, so that's linear, but if it is quadratic, for example, it is quadratic. If the curve is quadratic, the curve is something like this, something like that, right? If it is quadratic, then it's more complex. Yn equals to what? W0 plus W1 xn plus what? W2 xn squared. If it is cubic means that you have two inflection points. So you have two inflection points. This will be cubic. If you want to have a two inflection points, then yn will increase the complexity, right? W2 xn squared plus W3 xn power to 3. And so on and so forth, depending on how many inflection points that you want to have for your curve. And this is something that we do not know, whether this has to be horizontal line, whether this has to be linear, or whether this has to be quadratic or cubic. We do not know because we cannot see the data. We do not know the underlying curve of the data. So that's why we model it in more general way. How we can model it in general way is right yn equals to sum, because if you continuously it will be the sum, right? The sum of n equals to 0 until m minus 1. Wn xn power to what? Power to anyone? M, yes, power to n. This one is exactly the same, right? Exactly the same as whatever the expression that you have there. If capital N equals to 1, for example, if capital N here equals to 1, it will be horizontal line. If M equals to 2, it will be linear. And M equals to 3, it will be quadratic, and so on. So this expression here is more general, depending on your M. So now the complexity of the data, the complexity of the curve depends on the choice of M. So M represents the complexity of your model. So we do not know the value of M, and that's something that we model here in this equation. So there are many parameters that are unknown and very important unknown. One is the parameters of your model. This is WM is the model parameters. And the other important thing is this M
M is called what? Model complexity. That's right. This one is model complexity. So these are two important things in your data modeling. This is capital M, yeah. Also, thank you for correction. So this has to be capital M. Oh, sorry. This is no. This is correct. This is small M. Yeah, that's small M. The upper one. The model complexity. The model complexity is capital M. Yes. Yes. Okay. So any other questions or correction here? So model parameter is WM and model complexity is capital M. And this is something that we want to estimate. This is our goal. Machine learning goal is to find WM and capital M. So please understand this. It's very, very basic and very important. Okay. Any questions? Any other questions here? Okay, so once we have this, we can make this in different kind of form. I can write it in, normally I will write this here, instead of y, the yn, I will put it yxn and w bar. This one is more expensive, you know, including xn. Xn is the x-axis of your data. And again, W bar here is equally W0, W1 until what? W n minus 1. And what is the dimensionality of W bar? What is the size of this factor? N by 1. Correct? The vector size or dimensionality of the vector will be n by 1. Any questions so far? Now, this one is one data modeling, one data modeling. So this one is called one data modeling. One data modeling. Because it's only xn and yn. So this one is x and y. Forget what it is. So that's the data. That's one data. It means that if you imagine this, if you imagine this in the space, it's only that one. This is the year. This is the price, and that dot is actually in the. This one is xn, and that one is the n or yn because the n and y are identical. Oh, not identical, but actually absolutely opposite. That's how you model this one data here. So that's why I think it's important. Any question for one data modeling? Okay, so now, of course, our data is not just one. You have n data. So you have to have n data modeling, n data modeling. If you have n data, let's see. Okay, so before getting into n data, so for this data modeling, you can express this yn also in the matrix form or in the vector form. So normally people don't like this this sign of sum. People don't like that, right? If you have to remove the sum, what can we do? This one is yn multiplied by xn for every sample, right? So what you can do is to multiply this one in the factor form. For example, I can write W0, W1 until Wn, right? Oh, sorry, this n, Wn minus 1. This is dimensionality of W, right? I take this one from here. Yes. And then I multiply this with another factor, which is what the other factor? X. That's correct. So if I take the x, then it will be x and what is the power two? What is n? X n power two what? X n power two? X n power two? That has to be multiplied with this one. That one has to be multiplied with that. 0, of course, yes, that's multiplied. That one has to be 0, and then to xn 1 until xn m minus 1. This will be exactly the same, right? These two will be exactly the same. These two here will be exactly the same. Yes. So if I write it in the shorter form, in the simpler form, then what I have to write is W factor W, then what? X and factor. Is it correct? Is it correct or wrong? W transpose, exactly. So that's how you model in the factor form. So this is another expression that you need to keep in mind for polynomial function. So this polynomial function expression for one data. Any questions? Okay, so if there's no question, how about n data modeling then? So if you have y, now y is a y factor, and y factor here is more than one data. It means that we have y1, y2 until what? Y1. What is the subscript that I have to write here? No, that's wrong. This is talking about what? Talking about sample index. It's not the dimensionality index. So be careful that two subscript here. Two indexes here. One is for the sample index, and the other is for the dimensionality of your data. The dimensionality of your data, but the complexity of your model. So there are two indexes. One is for the sample index, and the other is for complexity of your model. So M, again, M is the model complexity. So M here is for the model complexity. But we also have N. N is a number, and is the number of your points. The number of your points here. So that's N. So in this case, because we have N data modeling, means that you have N samples. So you have N samples, and it has to be N. So Y bar, what is the dimensionality of Y bar? Anyone? N by 1. So this one, y n by 1 equals to what? It has to be the same as that of this one. But it has to be capturing all the samples. So how can we write this? In this case, so we will write H matrix multiplied by W bar. Okay. So it means that we have matrix X is x1. X1 here means that is point number 1, sample number 1. And this is the complexity of your 0. It means that the complexity of your model, the index of the complexity of the model. So you have x1 sample number 1, right? Until n minus 1. This is sample number 1. Multiplied by W. W is W0 until W n minus multiplied by minus 1. Yes. So this is exactly the same as one single data. If I write in this way, it is a one single data modeling. It's exactly the same as the one here for one data. If I have two data, what happens? If I have two data, then I have index 2, the second sample. This is the second sample. And I also multiply that with W. Okay. So if I have n samples, then I have xn here. Okay, so that's how you model n data. In other words, what is the dimensionality of X matrix?
N by M.
N by M, and W is
N by 1.
N by 1. So that's correct. So you cancel the parameters in the middle. Any questions so far? This is how you model the data and samples of data. Any question, anyone? Okay, so that's how we get the data here, I mean the modeling here. I assume that you understand this, so let's move on. So that's the first step. The second step, as we learned previously, is what? The first one is the data modeling. The second step is error function. So in the error function, we have EW bar equals to 1/2 sum over n yn minus en squared. And we can use a matrix form or factor form. In the factor form or matrix form for all the data, so for all the data, we can have 1/2 y bar minus p bar transpose y bar minus p bar. So that's what you do if you want to be in the factor form. So this one is again n by 1, this is n by 1, and you transpose that, it will be 1 by n. So the transpose of this will be 1 by n. Correct? And then this one is n by 1. So error function is always 1 by 1. Or error function is always scalar. Any questions so far here? Okay, so that's how you model this error function. And the problem is that the third step, which is optimization, you know that you have to find what? You have to find what is the final product of your training. To find what? To find W bar. In this case, we assume n is given. So here we assume that n is given. N is given. So least square doesn't solve the complexity data problem. It assumes that m is given. Now, if m is given, so we will see that this one is argument. I will talk about this later on, but if you just wonder in mind how we can find m, so m here is not really a problem of this square because it's assumed to be given. So now the problem then is to find the model parameters W star. So this means the candidate of all W EW bar. Now what can we do here now? After we get the optimization, what is the next step? The derivative. So now the derivative is that TE W bar divided by what? T of T what? Divided by T what? Well, if you have to have a W0, then you have to do all the things. W0, W1, W2, W3, W4, until W10 times 1, which is a lot to do, right? So you don't want to pick one. You want to form them together. Form them together W second. And this is called multivariate calculus. Calculus with multiple variables. Okay. So you have to solve this, you have to deal with this multivariate calculus. So now let's talk about this one has to equal to 0, right? We know mathematically it has to be equal to 0 because we know that we flat gradient for the error function. So what is the dimensionality of this 0? What by what? Anyone? So if you have, we know that E, what is the dimension of E? What is the dimensionality of E? 1 by 1, right? Is a scalar. Error function is always a scalar function. So what is W bar dimensionality? M by 1. So what is the 0 there? It has to be M by 1 because you have, W0, W1, W3, W1, Wn have its own solution. It means that if you have two W1 and W0, for example, you have the solution for W1 and W0. It's the same here. So you have multiple solutions. And the multiple solution here is represented by W there. So it has to be M by 1. It's actually a factor. 0 here is 0 factor. And the number of the 0 is M. So again, if you cannot imagine this, it's just basically 0, 0, 0, 0 until 0 there, and this is M0. Okay, so now how we can do this, right? So how we can do this computation of the derivative. So I don't want to dwell too much on this. You have to assume that you know to do the derivative of it. But if you don't, you just look at the lecture notes. Okay. So basically this one is dw bar 1/2 sum over n W transpose xn bar minus Tn squared. So you have to do the derivative based on this. So how to make a derivative of this is actually quite simple. You don't really care about W bar. You don't consider the factor. Because the operation for the factor, operation for the single variable is the same thing. So basically what you need to do here is that you cancel out the two, and then you have sum of n W transpose xn minus Tn multiplied by xn bar. So that's what you do when you do the derivative with respect to W transpose. Whether it's transpose or not, it doesn't really matter, but it's just a shape, right? The variable is not exactly the same. So let's check the 0 here have to be n by 1. So Tn, what is the dimension of Tn? What is the dimension of Tn here? This 1 by 1, right? Because it's a price. And it's just one sample of price. So if that's 1 by 1, it's going to be 1 by 1 as well. And what is xn here? xn is one sample, right? One sample depending on the complexity of your model. And the complexity of the model is m by 1. So that's match. So you have 1 by 1 dimensionality, it's a scalar, basically, multiplied by a vector. All right. So again, in this case, what you need to solve is W. You want to know W. So you can do the derivative here as much as you can. But I just want to point out that you can also use matrix form. So in the matrix form, so again, T, if you want to use the matrix form, TE TW equals to, let's see if I can make it matrix form. So again, I will not explain to you why this matrix form is look like this. But I refer to the lecture notes to see the exact derivative of this matrix form. Let's see how can I explain. Okay, so anyway, so let's first continue this one. So it seems that I can continue this way, and then I explain you later on as matrix form. So in this case, I just sum over n multiplied by xn w transpose xn, correct? If I put it inside, minus sum over n Tn multiplied by xn, correct? Now, this one, the first part here, I can manipulate this one into sum over n xn xn transpose multiplied by w bar. It's the same thing, right? I just rearrange in certain way. Yes.
Mention third one for the W bar.
So I put number here. That's number 1, 2, 3.
Number two.
Number 2. Yeah, xn is n. N.
No, the summation.
Yeah.
For the W bar transport xn and Tn.
Yeah.
IR.
So should be like this. That's correct. Yes. Thank you. Any other comments there? Okay, so number 4. If you have that one, then it's n, Tn, xn. Normally, I will not do this derivation because I assume that you can do the derivation by yourself. But for this first lecture, I will keep the details. So anyway, so in this case, what we can do is to remove the sum because we don't like the sum in mathematics. So how we can remove the sum is to transform this into a matrix. So in terms of a matrix, we can have x transpose x multiplied by w bar minus let's see minus x transpose multiplied by n. So again, this one is sorry, not sum is so again, if you look at the matrix here, matrix X, what is the dimension of X here? This one is n by 1, right? X is n by n. Transpose means that n by n. Correct? And X transpose, again, X transpose is n by n. And Tn, or sorry, Tn here should be T transpose. So the theta, and this one is T is a sample. It depends on the sample, right? T1, T2, T3 until Tn. So this one is n by 1. So in the end, this is the 0 here is n by 1. Again, maybe in your mind you ask yourself a question: how this one here become like that, right? I will not explain today. I will not explain now, but you can look at the lecture note. I'll put the details in the lecture note. But let's assume that we have this now. Let's assume that we have this. So let's assume we have this one. Now, what is the goal here? Anyone? What is the goal? What do we want to predict? Which value do we want to predict? W bar, exactly. W bar is something that we want to find. So because W bar is something that we want to find, then we can arrange this one into X transpose T bar. All right? And W bar equals to what then? W bar equals to is the inverse of what? X transpose X inverse X transpose T bar. So this is their solution to predict W bar in any integral form. But you have to set n, unfortunately, at the moment. At this moment, you have to set n, although n is not n just s, right? And then use this to predict your W. This square doesn't provide any opportunity for you to predict n, unfortunately. Okay? So that is a problem that we have to carry on in the next discussion, because we don't like this n, but we have to define it in this square. Any questions so far? Yeah. So in this case,
So line 2,
yeah,
how the middle line W bar transpose n becomes 1 by 1. I think that's actually
okay, so let's look at this. What is the W? What is the W transpose terminal thing? It's 1 by m, right? And what is n bar? N by 1. Yes.
Yes.
So this is multiplication of this is 1 by 1.
So on line 2, there should be
Oh yeah, this is the point. That's bar. Yes. Sometimes I forget about this. That's the bar. Because this is a complexity, model complexity. Right? Yeah. Oh, this one, yes. I often forget about the bar. So forgive me on that. Yes.
Still always like the extra transport X is invertible.
Say it again.
Is X transport X always invertible? Or sometimes it's not regular, we cannot convert it.
Yeah, that's good. So the assumption here, X transpose X have to be invertible to get the answer. If it is singular matrix of this multiplication, then you cannot get the answer.
So what should we do?
I will explain later on if you have time. That's another problem. Yes. Sorry. Yes, I will explain that soon here. So, any questions so far for this point here, up to this point? It is understandable, right? That's how you compute W, the model parameters in the training stage. That can be used for the testing. So you use the testing to check what is the prediction in the future for your price of the house. In basically, by knowing W and given your data, again, this is the concept of training and testing stage. Basically, if you given M, and it's again given, M is the model complexity of your polynomial function, then you can have this kind of function. So then, by having this line, you can predict the future. This is the future price. Based on the line, you can predict the future, or you can predict the past as well. And that's the benefit of having this W. Okay. Now, any questions so far here? So again, this is a training stage. Okay, so if that's no question, so we write W bar equal to X transpose X inverse X transpose T bar, right? So actually, this one is the definition of what? What kind of definition is that? This is the definition of pseudo inverse. So this one is actually the definition of X plus T bar. where X plus is pseudo inverse. So the solution for regression is very, very simple. You have the price, this is the price of your data, this is the price data, and this is the price of your year or your time. And then arrange in such a way that you have the pseudo of your year data multiplied by the price data. And then you can have the model parameters. Any questions here? So let's talk a bit about pseudo inverse. So you know inverse, right? So if you have A multiplied by A inverse equals to identity matrix. But this A inverse is possible when? How we can make sure that A minus is possible? What is the criteria of A to be invertible? It has to be, at least have to be, invertible have to be square, right? It has to be square in the first place. If it is not square, you cannot invert it. That is the first criteria. And the second criteria is what? Yeah, but that one is called non-singular. So a matrix can be inverted properly if it is square and non-singular. So now let's look at the first one, square. Your matrix is not always square, unfortunately. So for example, X here, so you see that X here, you remember what is the dimensionality of X? And no, X matrix. So X matrix. X matrix is n by n. N is the number of your samples, n is the complexity that you choose for your model. And m is not necessarily to be the same as n. Normally, which one is larger? Which one is greater, n or m? N is greater because n is the number of your sample. And when we talk about Amazon data, n is very huge, million, right? But your complexity of your data is not necessarily to be that high. Maybe 10, maybe 50, maybe 200, but it's not up to million. So basically, if it is not square like this, if it is not square, what can you do? If you have to invert it, for example, if you want to invert X, which is not square, which is n by n, what do you do then? Yes, you have to use pseudo inverse. So you have to make it a pseudo inverse. And the pseudo inverse definition, one of them at least, one of them is this one. That's how you make the X to be invertible because it's not square. And there's interesting things about non-singularity, right? Non-singularity is something to do with deterministic system and non-deterministic system. Underdetermined and overdetermined system. There is something in the physical underlying intuition that is interesting about non-singular matrix or singular matrix. But unfortunately, I don't have time today, so we will review again or have a recap again in the next lecture, and hopefully I can have time to explain the non-singularity matrix in relationship with the underdetermined system and overdetermined system. All right, last time questions here. Any questions before we end the lecture today? All right, so that's all the day. Thanks everyone. I will see you next week.
No, it's regarding 5026. I tried to register for that number, but it was not there.
Oh, you have to contact the, yeah, you have to contact the admin people. Yeah.
So, for 5 years,
Yes.
exam will be in November.
No, in the research. Yeah. Yeah.
For pipeline filter and
No, no, no.
that's what I have a question about the civic numbers and also that definition of
It's one of the definitions. Yes.
but you assume that next chapter has to
Yeah, yeah. That's one that I already answered the question. That is have to be inputable. It's assumed to be inputable.
yeah, but I mean if it's not included,
Then you cannot have the answer. Means that it's not the system is not solvable.
yeah,
Yeah, exactly. Yeah. There's no singularity that I want to mention.
It's only the form of the left, and the right student.
Yes. So next week, hopefully, I have time to explain overdetermined system and underdetermined.
Yeah, so actually, this is.
Yes, exactly, exactly. Yes. Unfortunately, I don't have time. Yes. Yes. Oh. Hello, I have stuff here forgotten. So if you have this, please pick this here. There's a pocket here, someone left.
Yeah, so our actually overseas for 2 days. Sometimes
So you're the official students. Okay, so there is no attendance necessary, and actually I do the recording. Hopefully the recording works. So you can look at the recording.
but I'm worried about that. Like because I saw like every 24 hours they actually want to see. So
Okay.
I think during the break I will actually be able
So
to.
you are the student of this. No, you're a first student.